Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on complex analysis power series lecture number 7, in which I will state and prove Taylor's theorem. Firstly, we state Taylor's theorem statement. Let function of z be analytic at all points within a circle C0 with center Z0 and radius ρ0. Then for every point Z within the circle C0, we have function of Z equal to function of Z0 plus Z minus Z0, first order derivative of function of z at the point z equal to z0, plus z minus z0 whole square by factorial 2 multiply second order derivative of function of z at the point z equal to z0, plus plus z minus z0 whole to the power n by factorial nth order derivative of function of z at the point z equal to z0 plus . In short, this equal to function of z0 plus sigma n equal to 1 to infinity z minus z0 whole to the power n by factorial nth order derivative of function of z at the point z equal to z0. Now we prove this. Since given that function of z is analytic at all points within a circle C0, let this is the circle C0. Function of z is analytic within all points of the circle C0, and center of the circle with center z0 and radius ρ0. Let this is the center z0 and radius be ρ0. Therefore, equation of the circle will be modulus of z minus z0 equal to ρ0. Let this is number 1. Let z be a point within the circle C0. Let this is z. Now let we draw a circle C with center z0, radius ρ, and let the point z is within the circle C. Let we draw a circle C. Z be the point inside the circle, and let the radius of this circle is rho. Let xi be an arbitrary point on the circumference of the circle C. Therefore, let xi be any arbitrary point on the circumference of the circle C. Therefore, xi minus z naught modulus equal to rho. Let this is number 2. Let modulus of z minus z naught means distance between 2 points z and z naught equal to r. Since z is inside the circle C, therefore r, this is the distance r is less than rho. Therefore, r is less than rho implies that r by rho less than 1. Let this is number 3. Since given that function of z is analytic at all points within the circle C naught, and the circle C is inside the circle C naught, therefore function of z will be analytic at all points within the circle C. Since z is a point inside the circle C, here z is inside the circle C, therefore by Cauchy's integral formula, function of z equal to 1 by 2 pi I integration along the circle C, function of xi, here variable is xi, on the circumference of the circle by xi minus z d xi. Let this is number 4. Now one by xi minus z equal to 1 by xi minus z naught plus z naught minus z. This will be equal to 1 by xi minus z naught minus z minus z naught under bracket, and this will be equal to 1 by xi minus z naught common 1 minus z minus z naught by xi minus z naught implies that 1 by xi minus z equal to 1 by xi minus z naught multiply, we take to the power minus 1. 1 minus z minus z naught by xi minus z naught to the power minus 1. Let this is number 5. Since from 3 r by rho less than 1 implies that modulus of z minus z naught by xi minus z naught less than 1. Let this is number 6. Using 6 in 5 and then by binomial theorem, 5 can be expanded as 1 by xi minus z equal to 1 by xi minus z naught, 1 plus z minus z naught by xi minus z naught plus z minus z naught whole square by xi minus z naught whole square plus dot plus z minus z naught whole to the power n by xi minus z naught whole to the power n plus dot. This is number 7. Using 7 in 4, we get function of z equal to 1 by 2 pi I integration along the circle C, function of xi multiply 1 by xi minus z naught 1 plus z minus z naught by xi minus z naught plus z minus z naught whole square by xi minus z naught whole square plus dot plus z minus z naught whole to the power n by xi minus z naught whole to the power n plus z minus z naught whole to the power n plus 1 by xi minus z naught whole to the power n plus 1 plus z minus z naught whole to the power n plus 2 by xi minus z naught whole to the power n plus 2 plus dot dxi equal to 1 by 2 pi I integration along the curve C, function of xi multiply 1 by xi minus z naught 1 plus z minus z naught by xi minus z naught plus z minus z naught whole square by xi minus z naught whole square plus dot 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 plus we take common here z minus z naught whole to the power n by xi minus z naught whole to the power n remains 1 plus z minus z naught by xi minus z naught plus z minus z naught whole square by xi minus z naught whole square plus dot 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 plus z minus z naught whole to the power n by xi minus z naught whole to the power n plus dot 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 d xi. This equal to 1 by 2 pi I integration along the circle C function of xi. Now we take 1 by xi minus z naught 1 plus z minus z naught xi minus z naught plus z minus z naught whole square xi minus z naught whole square plus dot 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 plus z minus z naught whole to the power n minus 1 by xi minus z naught whole to the power n minus 1 plus z minus z naught whole to the power n by xi minus z naught whole to the power n multiply. We multiply this with here 1 by xi minus z naught here 1 plus z minus z naught xi minus z naught plus z minus z naught whole square xi minus z naught whole square plus dot 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 bracket close d xi implies that function of z equal to here 1 by 2 pi I integration along the curve C circle function of xi bracket 1 by xi minus z naught curly bracket 1 plus z minus z naught by xi minus z naught plus z minus z naught whole square by xi minus z naught whole square plus dot 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 plus z minus z naught whole to the power n minus 1 by xi minus z naught whole to the power n minus 1 plus z minus z naught whole to the power n by xi minus z naught whole to the power n and value of this by 7 left side 1 by xi minus z dxi using 7. Since in 7 we see that 1 by xi minus z equal to 1 by xi minus z naught bracket, and here 1 by xi minus z naught bracket, same thing under bracket. So in this place we have written 1 by xi minus z, implies that function of z equal to, we take separate integration 1 by 2 pi I integration along the circle C function of xi by xi minus z naught dxi, plus, since the variable is xi, so we may take outside z minus z naught, z minus z naught by 2 pi I integration along the circle C function of xi by, we multiply this xi minus z naught whole square dxi, plus we take z minus z naught whole square outside, z minus z naught whole square outside by 2 pi I integration along the circle C function of xi by xi minus z naught whole cube dxi, plus dot 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 dot, plus here we take z minus z naught whole to the power n by 2 pi I integration along the circle C function of xi by xi minus z naught whole to the power n 1 by xi minus z dxi, implies that function of z equal to, here from Cauchy's integral formula, this means function of z naught plus here z minus z naught, and from derivative theorem, first derivative, this is function of derivative of function of z at the point z naught, plus this is z minus z naught whole square multiply, here from second derivative, this is equal to by factorial to function double derivative at z equal to z naught, plus dot 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 dot, plus, let this value is Rn, this is number 8, where Rn equal to z minus z naught whole to the power n by 2 pi I integration along the circle C function of xi by xi minus z naught whole to the power n multiply 1 by xi minus z dxi. This is number 9. Since xi minus z equal to xi minus z naught plus z naught minus z equal to xi minus z naught minus z minus z naught modulus xi minus z modulus equal to modulus of xi minus z naught minus z minus z naught. This is greater than equal to modulus of xi minus z naught minus modulus of z minus z naught, and this is equal to xi minus z naught is rho and this is r z minus z naught, implies that modulus of xi minus z greater than equal to rho minus r. This is number 10. Using modulus in both sides of 9, we get modulus of Rn equal to modulus of z minus z naught to the power n by 2 pi I integration along the circle C function of xi minus z naught whole to the power n multiply 1 by xi minus z d xi. This is less than equal to modulus of z minus z naught whole to the power n modulus of 2 pi I integration along the circle C modulus of function of xi modulus of xi minus z naught to the power n 1 by modulus of xi minus z modulus of d xi, implies that modulus of Rn less than equal to modulus of z minus z naught is r to the power n modulus of 2 pi I, modulus of I is 1, so here 2 pi integration along C modulus of function of xi is less than equal to m, a positive quantity, since it is bounded, so here we write positive quantity m, and xi minus z naught, this is rho to the power n, and modulus of xi minus z is greater than equal to rho minus r, so if we write here lesser quantity, right side will be greater, here greater, so 1 by rho minus r modulus of d xi, implies that modulus of Rn less than equal to r to the power n by 2 pi. Here we may write modulus of I equal to 1 function of xi modulus less than equal to m positive quantity. M outside, rho to the power n outside, 1 by rho minus r outside, integration along the circle C d xi modulus, implies that modulus of Rn less than equal to here m by 2 pi r by rho to the power n 1 by rho minus r, and this means circumference of the circle C 2 pi rho and this tends to 0 as n tends to infinity, because since r by rho less than 1, this is a very small quantity, and if we take the power infinity, this will tends to 0, implies that Rn equal to 0. Let this is number 11. Therefore 8 may be written as function of z equal to function of z naught plus z minus z naught by factorial 1. First order derivative of function of z at z equal to z naught plus z minus z naught whole square by factorial 2. Second order derivative plus dot 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 dot. In short, we may write function of z equal to function of z naught plus sigma n equal to 1 to infinity z minus z naught whole to the power n by factorial n, nth order derivative of function at the point z equal to z naught. So proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.